Hello wonderful person, this is Anton, and in today's video we're going to go and look for water in our solar system. You're going to find out the most likely places we can find quite a lot of water in our beautiful solar system, and you're going to learn about the ubiquity, in other words, the availability of water pretty much everywhere around our sun. Anyway, welcome to What the Math. So I know, I just spoiled it for you, water is everywhere. But let's actually take a look at some of the very unusual examples, but specifically we're going to take a look at the examples where we think there's like tons of water. First of all, Mercury, which is ridiculously close to the sun, has water. That's right. Mercury is very, very hot. The temperature here currently is something like 183 degrees Celsius. But inside of these craters, specifically on the dark side, that are always hidden from the sun, we actually have detected water ice specifically. Venus is the hottest planet in our solar system, and even it has a bit of a water vapor emanating from its surface. Not a lot, something like 20 particles per million, but it's definitely there. What's even more interesting is that Earth does not actually have the most water in our solar system. As a matter of fact, Earth, in comparison to some of the other objects we'll be looking at, is very, very mediocre in terms of its water quantity. So, let's begin with some of the more interesting examples. And we're going to go ahead, escape our Earth system, and go to the first object closest to us that has quite a lot of water on it. And that's the object known as Ceres. This is a dwarf planet, formerly an asteroid, and previously to that it used to be known as a planet. And this is something that we've actually studied for quite a long time. There was actually a probe orbiting around Ceres for quite a long time, and we have quite a lot of information about it. And this right here is actually one of the signs of ice water on Ceres. So Ceres has tons and tons and tons of water. It probably came from the same source where Earth has it, basically, and we're not really sure where we got water from. We used to think it was from comets, and we used to think it was like basically from various collisions onto the surface of our planet. But then we realized that the water in comets seems to be different from the water on Earth. So maybe, just maybe, this is not actually how we got the water. But we know that Ceres has a lot, so does Earth, and the water on Ceres is very likely going to be similar to the water on Earth. Alright, so what's the next object that we're going to take a look at? And look at how beautiful these particles are. This is from the collisions with those asteroids. Anyway, moving on to the next object. And we're going to skip Mars because we know that there is some ice water on Mars, but not enough to be interesting. We are going to go to Jupiter though. Jupiter is the number one place for water in our solar system. Jupiter has the most water ever. As a matter of fact, it has more water than all of the objects combined. All of it, though, is in gas form and is also underneath this top layer of hydrogen. So most of the water on Jupiter is inside and is kind of unreachable to us. In other words, it's not particularly interesting, but we know that it's there. However, what we are going to take a look at is we're going to take a look at some of the moons of Jupiter, because we know that some of these moons have very, very interesting structure. Let's start with the first of the so-called Galilean moons. Actually, not the first, second. We're going to skip Io because it's not really a source of water. We're going to go to Europa. This is probably the most interesting object in terms of looking for water, because we know that Europa is essentially covered with water ice shell, and underneath this we think there is actually an ocean, a liquid ocean filled with potentially life, maybe, we don't know, but it's possible. We also think that this ocean here is about 4 times bigger than the total amount of water on our planet Earth. So there's a lot and a lot of water on Europa. Two similar objects are Ganymede, which may actually have an ocean underneath too, underneath this rocky shell. but possibly not as much as Europa. And even though Ganymede is actually #1 biggest moon in our solar system, it's very likely that it's more rock than water. And we also have the farthest satellite, known as Callisto, that is, for some reason, appears black here. Here's an actual picture of Callisto from the internet, and basically here, we also think there's quite a lot of water as well. So these three objects together constitute quite a lot of ice water, but also very likely liquid water inside of them. We're not 100% sure yet, but we think that the chances for liquid water inside of those objects is very, very, very high. Alright, moving on to Saturn. Around Saturn we have several interesting satellites, and specifically the one that I really like to talk about is Titan. But unfortunately, Titan very likely has almost no water, or possibly no water whatsoever. It does have a lot of liquid on the surface, but all of this liquid is either methane or ethane. So no water here. We can kind of forget about Titan for now. However, there's at least 2 satellites here that are very interesting. And the most interesting one is, or has been recently in the news, Enceladus. Now this one is very, very small. It's actually only about 252 kilometers in radius. So in comparison to, let's just say, Ganymede, it is much, much, much tinier. So there's the size of Ganymede in comparison to Enceladus. But we know almost for a fact that this particular satellite has a liquid ocean underneath, and very likely a lot of hydrothermal vents inside of it that on our planet Earth are responsible for quite a lot of life. So currently this is actually a #1 spot to find life, but also definitely has liquid ocean underneath. And except for Enceladus, there's another one orbiting around Saturn here. Let me just try to find it. So there's Mimas, which is actually one big snowball. Basically, this is one ice ball orbiting around Saturn, so there's quite a lot of water there as well. And we also have Dione, which is right there. A very, very beautiful satellite in this particular simulation, but doesn't actually look like this in real life. And so Dione also very likely is similar to Enceladus, a little bit bigger than Enceladus. And so here is Enceladus in comparison to Dione. It's basically just a little bit smaller. But yeah, we think that there is very likely some liquid water underneath and quite a lot of ice water on the surface as well. So that's the satellites of Jupiter and Saturn, and there's at least 3 per planet that have quite a dramatic amount of water inside of them. But that's not it either. As we keep going further and further away from our sun and move toward the outer planets, we discover even more water. So Uranus, for example, also has quite a lot of satellites, and even though we haven't really studied these satellites in a lot of detail, we are kind of pretty sure that almost all of these contain a huge amount of water as well, mixed with all kinds of rock. And finally we come to the last planet here, and this is of course Neptune. And Neptune definitely has quite a lot of satellites with ice, but one that we are almost certain has quite a lot of ice is Triton. This is actually an object that was very likely captured from the outer solar system, from the Kuiper Belt, and it's a very, very large satellite compared to other objects here. Maybe not as big as, say, Ganymede, but in comparison to Enceladus, it is much, much larger than Enceladus. So there's Enceladus right next to it. So Triton also has quite a lot of water, possibly even the liquid water inside, because we think there is some sort of a reaction going on that allows for the nitrogen from the surface to escape and to produce very thin atmosphere. And speaking of Triton, it's also very, very similar to another object that we all know and love, and that's of course Pluto. Now Pluto, that's right there, also very likely has quite a lot of ice water, but also maybe even liquid water inside. We're not exactly sure if there is any liquid on the inside, but there is a slight chance that it might have a bit of a liquid ocean inside, because for the most part, this is all ice. Methane ice, water ice, and so on. Alright, so far we've found ice water and even liquid water pretty much everywhere in our solar system. And interestingly, every single one of these objects you see, every single object past Neptune, also known as trans-Neptunian objects, and all of these dwarf planets like Quasar, 2002, 2M-S4, Varda, all of them have water. All of them have a huge amount of water. Lots and lots of ice water, and some of the bigger ones, the ones that can possibly maintain some kind of a pressure within, might even have liquid water inside. And so all in all, if we were to actually combine all of this water into one big chunk, we would possibly create a huge water planet. And let's actually maybe even try this right now. So here are these 9 objects that we're going to be adding together. And they're basically Ganymede, Callisto, Europa, Triton, Pluto, Dione, Ceres, Enceladus, and Mimas. And we're really basically ignoring Jupiter because most of the Jupiter water is in gas form. And what we're going to do is, well, let's actually just have them collide with each other and see how much water will create and how big of a planet we'll be able to make by combining all of them together. And so here we go. They're going to be colliding with one another relatively soon. I'm not exactly sure why Dione decided to explode right away. That's very interesting. But there are those explosions. There are those collisions. And hopefully by the time that they're finished colliding, we'll have a humongous water bowl of an object with quite a lot of interesting materials around it. We might need to actually stop velocities here just so that they actually absorb all of the materials together. And here we go. So this is a mega-sized Ganymede. We're going to lower the temperature because it's otherwise going to evaporate all of the stuff from the surface. And here we go. So this is Ganymede at about 10 degrees Celsius. Let's look under the materials here and we'll discover that, okay, so it's about 17% water, which in total, in terms of sizes of moons, is about 76%. So this is about 76% moon mass, and all of this is essentially water. So imagine having an object that's basically size of our own moon, which is about this big, and all of this would be essentially just pure water. So we're going to place this in orbit here, turn this into water, and this is essentially how much water there is inside of this humongous, beautiful object that you see cooling down right now. So, hopefully from this video, hopefully you learned something from this video, and hopefully now you know that water is everywhere in our solar system, and now you know these 9 or specifically 10 objects where we can find quite a lot of water in our solar system. In other words, it's, you know, everywhere. If you've enjoyed this video, don't forget to subscribe and don't forget to share this video with someone who enjoys watching space videos, science videos, or educational videos and wants to learn through video games. Come back tomorrow to learn something else, and I'll see you tomorrow. Space out, and as always, bye-bye. And let's actually accelerate this a little bit more, wait for this to cool down, and see what this object looks like after a few hours. And look at that, it's actually a legit water world, with some occasional craters from the explosions. And now it's an ice world. Very, very cool. Very beautiful and very awesome.